let us talk about, let me go here to area first. Yeah, we'll go over area first. Okay, but before we do that, there are a couple of things that you are going to need to know. And the only way to know these is to memorize them, or you already know them. All right, so a rectangle, the area of a rectangle, so A means area. Area of a rectangle is equal to its base times its height. Okay, the base times the height. Now, a square is also a rectangle, but it is a rectangle whose square and height are the same. But rather than try to remember two different formulas, just remember base times the height. Okay? So this formula is not given on the case. It's something that you have to know. The same things if you have a parallelogram. Okay? The base is just this flat portion here. The height is not the slanted height. It's the height that if you were standing on the edge and you drop something down, that is your height. So the area of a parallelogram is also base times the height. Okay? The area of a triangle is equal to half the base times the height. So if you have a triangle like this is your base, this is your height. You have a triangle that's like this is your base, and this is your height. It's always the vertical height. Okay, so it's half the base times the height. So what you do is you multiply base times height, take half, or divide by 2. So those are things that you need to know, and they're not going to give you those on the casing. The other things that you need to know is the conversion of millimeters to meters. So here in the United States, we don't use the metric system. We use the English system. So a couple of things. There are 1,000 millimeters in a meter. M equals millimeters. There are 1,000 meters in a kilometer. There are 100 centimeters in a meter. Okay. Now sometimes they may give you one of the other metric units. Sometimes it'll be gram. Okay. And what you'll have to do then is the same thing. 1,000 milligrams is equal to a gram. Okay. 1,000 grams is equal to a kilogram. We usually don't use centigrams. Okay. So those are parts of the metric system. Okay. And so you may run across some of those. All right. Something else there, you may know this already, there are 12 inches in 1 foot. There are 16 ounces in 1 pound. Pound we write as LB. There are 60 seconds in 1 minute, and then 60 minutes in 1 hour, and then 24 hours in 1 day. So you may or may not know these, but these are things that will be on the KC that they may not provide formulas for. Other things that they may not provide formulas for. Does anybody have any questions on these? The area of a circle. The area of the circle is equal to pi. That's our magic number, 3.14. And every March 14th I go by pi. Times the radius square. The radius is the distance from the center to the outside. Okay? The circumference, which is the distance around, like a track, if you ran around this, is equal to 2 pi r. Some people like to write it as pi d, and the diameter is just the total distance across going through the middle. So you can do it either way. If they give you the diameter, then just do pi d. If they give you the radius, then just do 2 pi r. So either way, they'll give you one, you can just calculate the other. Okay, if you have some sort of box, they call them rectangular solids. Okay. There are two things that they may ask you about for this. There's the volume, and then there's the surface area. Okay? So we do length, width, and height. Okay? So to get the volume, it's the length times the width times the height. Okay? To get the surface area, you have to think about the way a box is designed. It has 6 different sides. So we see 3 of them here, the front, the top, and this side. But each one of these has a counterpart. There's a back, a bottom, and another side over here. So to calculate the surface area, we need to find the area of each one of these, okay? And then multiply it by 2. So the area of this part here facing us is this times this. So it'll be the length times the height, okay? If we look at the top here, it's the width times the length. And if we look at this guy here, it's the width times the height. And there are 2 of them, so there's 2 times this one, plus 2 times this one, plus 2 times this one. That gives us the surface area. And if you wanted to think of surface area, if you want to know the difference between volume and surface area, volume is if you were to open up the box and fill it up on the inside. So if you were to open the box and then fill it with candy, that is volume. If, however, you were going to paint the box, that would be surface area. Paint the outside of the box would be surface area. So the surface of what you would paint, the whole box, all 6 sides of it would be the surface area. What you put inside would be the volume. Okay? So these are just formulas that, unfortunately, they will not give you on the KC, so you have to just know them. Okay? All right, so let us look at some problems here. This one, this one. All right, so we are on page 29, and we're going to go through some of these problems together. All right, so we are on page 29. All right, use the following diagram to answer the question that follows. Circle O is inscribed. That means it's inside, totally inside, touching the sides of the square. It's inside the preceding figure. The area of the shaded region is approximately, okay? So, how would we figure this out? Well, we know from this that there's a circle in the middle, and we know the area, right? And then we know that a square has equal sides. So let us look at this guy. All right, pretend like I think that's right. So if it's a square, that means this side is 10 and this side is 10. And so we know the area of a square is, or any rectangle, is base times height. So we know the area of the square going to be 100. They didn't give us any units. 100 feet, 100 centimeters, all right? We know that the radius of a circle is this distance here, right? Which, if you look here, that happens to be half the distance across. So the radius here would be 5, right? Because the whole distance across would be 10, half would be here, okay? Now to find the area of a circle is equal to pi r squared, all right?
No.
So the area of this whole circle is pi r squared. We would then multiply that. That would be r squared is, we know from our exponents, that would be pi times 5 times 5, which would be 25 pi. So we're going to leave it that way for a moment. That'll be 25 pi. All right. 3.14, approximately 3. So we're going to say that the area of the circle is about 75, right? 3 times 25. So if the area of this whole thing is 100, and I cut out 75, what do I have left? Well, let's look here, right? We cut that out. We have 100 minus 75 will give us 25, right? Okay? And so, but they don't want to know, how much all of these are. They only want to know 1/4. Well, there's not a fourth of 25 that's close enough. So since they said approximately, what's the closest thing that we can get to 25 divided by 4? What's the closest number that we would get? So 25 divided by 4 is 6 1/4. So that's the closest. So what's the closest number that we can get out of A, B, C, and D? Which of those is the closest to 6? 10, 25, 30, or 50? 10. And that's what they did. So you notice they didn't give you a nice, clean, pretty answer. They gave you, because they used the word approximate, you had to do a couple of steps and you ended up with 10. So you wouldn't look at that and say 10, but they used the word approximate, okay? And they show you the steps here, and they did it the exact same way. You found the area of the outside, you find the area of the center, cut it out, what's left, and then you divide it by 4. So they wanted to know this. And because they said approximate, you're not going to get the perfect answer, right? Because we didn't use the actual values anyway. So we used 3 instead of 3.14, okay? Let's see. Let's jump over to 31, and we're going to talk about similar figures. Now, similar figures are pretty straightforward. Essentially, they're the same shape but different sizes. Okay, so I can have a triangle like this, and then I can have a triangle like that. And I can have a triangle like that. They are similar if the angles are all the same. Okay. And the relationships between the two parts are the same. So if this is a 2, then that would have to be a 4. If this were a 5, then that would have to be, this is a 2 and this is a 4, that's a 5, this would have to be a 10. Twice as big, right? I'm sorry, 8. No, that's right, 10. Well, that's right. Twice the size, right? So that's what they mean by similar. Okay? So if you look at number 8, if the smaller one is, that length is 8 inches, and you look at the larger rectangle, that one is 24. 8 times 3 is equal to 24. So h would have to be what? To go from 8 to 24, I multiplied by 3. So to get h, I'd have to multiply 4 times 3. Okay? And that would give me 12. So it's essentially the same as finding a common denominator, okay? So 8 over 24 is equal to, I can do the other way, 4 over 8, I'm sorry. So it's essentially the same as when we found common denominators. 4 over 8 is equal to some number over 24. 8 times what gives us 24? Times 3. Whatever we do to the bottom, we do to the top, and that would give us 12. Okay? So that's what similar figures look like. Similar figures, again, have to do with the angles being the same and the sizes are proportional, meaning they are the same factor or multiple of the other. So if this one's twice as big, then this one has to be twice as big. If this is a third as big, then this one has to be a third as big. So the relationship between the sides has to be the same for all of them. Okay? Any questions? All right, let us look here. We are going to talk about the Pythagorean theorem. One of my favorite things in all of life. Have you guys been telling yourselves that you love math? You must love math. You're only good at things that you love. You must love math. Okay, so if you have a triangle and that triangle has a right angle, and a right angle simply means it's 90 degrees or a perfect L. Okay, and they show a 90 degrees by putting a little square there so that you know it's 90 degrees. If you have a right triangle, and this is called a right triangle, and again, this is something you're just going to have to remember. Okay? If this is side A, and this is side B, and this is side C, usually we write side C as the one that's opposite of the right angle. And it has a special name. The side that is opposite of the right angle is called the hypotenuse. Okay? And the cool thing about right triangles is the relationship between the hypotenuse and the sides is always the same. So, if you were to square the hypotenuse, it's equal to one side squared plus the other side squared. And we remember from our lesson on exponents, square just means this. C times C is equal to A times A plus B times B. Whenever you have a right triangle, this is always the case. And what they will do on the KC is they're going to give you any two of these numbers and you have to calculate the third one. Okay? So if they were to give you something like this were 3 and this was 4, and they want you to find that, they would say C squared is equal to 3 squared plus 4 squared. 3 squared is 3 times 3, which is equal to 9, plus 4 times 4 is equal to 16. That's equal to C squared. C squared is equal to 25. But they're not asking me for C squared, they're asking me for C. So what number times itself gives me 25? What number, when I multiply it by itself, will give me 25? That would be 5, right? So that's what they're going to have you do. They're going to give you any two of them, and you have to solve for the third one. Okay? And that's what the Pythagorean theorem is. So they may give you something like, oh, I don't know. No, let's do. All right. They may say, all right, fine. We'll give you, this is an A, by the way. We'll give you this one. So we know the formula is C squared, so 13 times 13. 13 times 13, 3 times 3 is 9. 3 times 1 is 3. 1 and 3, that'll give us 169. 169 is equal to, bye-bye, a squared, because we don't know a, plus 5 squared, which is equal to 25. Okay? We'd have to subtract 25 from this side. Whenever we do to one side of the equation, we have to do the other side. And we'll cover that a little bit later if you haven't had that. That'll be 144 is equal to a squared. So what number times itself gives you 144? 12. So a would equal to 12. Okay? So they'll give you any two, and you have to solve for the third one using the Pythagorean theorem. Okay? All right, let's see. All right, let's do volume 1. Kind of covers surface area. I thought I had a volume 1 here. Okay, let's look on page 36. Okay, so if we were just to look at the volume, let's not look at the question. If we were just to look at the volume is length times width times height. So in this instance, the volume of that box is 8 times 16 times 9. Okay, and those are all in inches. And so we would multiply that out. 16 times 8, 8 times 6 is 48, carry 4. 8 times 1 is 8, plus 4 is equal to 128. Then we'd have to multiply that by 9. 9 times 8 is 72, carry our 7. 9 times 2 is 18, plus 7 is 25, carry our 2. 9 times 1 is 9, plus 2 would be 11. So 1152 is the total volume of that. Now let's look at the question and see what they're asking. Okay, so what is the maximum number of milk cartons 2 inches wide by 2 inches long by 4 inches tall that can fit into the cardboard box with inside dimensions 2 inches wide by 9 inches long by 8 inches tall? Okay. Well, that's kind of easy. We don't even have to really do any calculations, all right? So let's just look side by side, all right? So 2 inches wide, if each box is 2 inches wide and we have 16 inches, then that would be 8 in that direction. If we look in the other one, we have 3 in the other direction, because 9 divided by 3 is 3. And then we'd have 8 divided by 4, which is 2. Or you can look at the diagram there and then just count them. Okay? And then you would see that we have 48 possibilities. Okay? And essentially what we have is we have in one direction, we have 8 going this way, we have 2 going this way, and then we have 3 stacks. So that would be 8 times 3 times 2. So these are just the different type of geometry questions. So what you're going to do on your own, well, I'm going to cover one more before we do that. No, that's fine. I want you to go through and work on the ones that are listed here from 29 through 44. And on Monday, we'll do a review just to make sure you understand them. And then we'll go on to the next section. Question? No. Okay. All right.